Hello and welcome back to the channel. This video is working off a premise that you went out and you bought a GMRS Mobile, put it in your car, and you liked it so much that you decided to go out and buy another one and put it in your house. So you put it in your house on a 12-volt power supply, and now you need an antenna. So you could just order one on Amazon and wait for it to be shipped to you, or you could get creative and build one. And that's what we're going to do in today's video. I'm going to show you how to build an easy to build GMRS J Pole out of readily available components. The only fancy thing that you need is a jumper, so a CB jumper, something similar. Everything else can be bought at any hardware store, and it's relatively cheap. We're talking less than 30 bucks worth of materials, and it won't take very long to build it either. I'm gonna set myself a goal. I want to build this antenna in 20 minutes flat, and that's my goal. We'll see if we attain that goal or not. And what you're going to need to do this is you're going to need a CB jumper, and you're going to whack one end off and separate the center conductor and the shield. And you're going to need a drill. You're going to need a piece of house wire. This is just standard 14 gauge solid copper insulated house wire. This happens to be about 26 inches long. That's what you'll need to start with. You'll need a piece of plumbing pipe. This is 3/4 PVC. It's the thinnest stuff that's available. It's 200 PSI rated. And if you look, you can see that SP200, or PR200 in this case. Deviating from this style pipe might change the length of your wire a little bit. So I recommend using this pipe. It's the thinnest PVC that you can get, and works great for me. This is what I use. You'll need a couple caps, 3/4 caps. You'll need a drill bit, and the drill bit needs to be the same size as your coax. So in my case, my coax is, well, that's 234 thousandths, and the drill bit that I've chosen is 242 thousandths, maybe just a hair bigger, but it'll work. You'll need a soldering iron. You'll need some solder. You'll need something sharp to trim back the insulation on our house wire. You probably need a pair of snippers. And I just remembered you're going to need a pair of, there we go, need one of those pliers. This is for bending the house wire. You're also going to need some blue tape, and I'll go grab that in a minute. But anyway, let me set this up and get started. I'm going to set a timer, and we're going to try and build this antenna in exactly 20 minutes flat. Okay, here we go. So this piece of wire is cut about 28 inches long, I believe. It's just 14 gauge house wire is all this is. Solid copper with insulation on it. And that's going to be the basis for our antenna. And here's the dimensions I'm going to be using. So the matching section is 5.5 inches. The half-wave dipole section is 12 3/4 inches. And the feed point's at 5/8 inches. Those are probably a little bit long. Once we get tuning this thing, we'll see if that's going to work for us or not. So let me start the timer. And we're off. So the first step is to measure out our matching section at 5.5 inches. I'm going to start at the inch mark because the end of these are always sloppy. That's 5.5 inches right there. I just put a 90-degree bend, and then I'm just going to make another bend. And you determine this bend by the pipe. So the inside of this 3/4 pipe, this has to slide up in it when you're done. So it needs to be roughly about like that. And then we can test this. Perfect fit. And now we need to do our half-wave dipole section, once again starting at 1 inch. And we're going to measure out 12 3/4 inches, which is going to end up right there. There's our J pole. Now some of you might be thinking, why don't you just use twin lead? And yes, you can make them out of twin lead, but who the heck has twin lead around their house? I certainly don't. So years ago, twin lead used to be very common. Everybody used it on their TV antennas, but not anymore. It's a special order item anymore. Okay, our feed needs to be 5/8 of an inch from the inside of the bend, and the reason for that is because the inside of the bend is the shortest path for the electrons. There's our 5/8 mark, and I just took a razor blade and we'll score on both sides of that mark. We just need to get the insulation off and get down the bare copper. Wire strippers would work just as well, or maybe even better. Once we get that scored all the way around, I'm just going to cut on the outside. And I'm going to tin this real quick. Okay, then we need to drill a hole in our cap. Once again, the hole is going to be the same size as our coax, and then once you get your coax shield away from your center conductor, you just run that up through the bottom. Pull it up about 1 foot. An alternate method to do this is to put an SO239 connector in the base of this, use a bigger hole, slide an SO239 in there and go that route with the barrel connector, but this is actually much easier. And then we're going to solder this in place. I've already got these tinned. Center conductor to the long leg, shield to the short leg. and you want the edge of the wire to be at the 5/8 inch mark. So 5/8 of an inch from the inside of the bend is where that's going to end up. Like so. Seems to be pretty good. Okay. Once you do that, then it's just a simple matter of sliding the wire inside the pipe. Oh, forgot a step. Take a piece of blue tape or masking tape. And we just want to add some rigidity here. Try and keep the spacing the same. Okay. And just slide the cap on. There's no need to glue it. And with that, we're ready to test. I'm going to use a nano VNA to test this. And I know some of you are thinking, oh wait a minute, Rick, doesn't the nano VNA kind of blow the budget on this deal? But I ask you, would you go buy an antenna, order it from Amazon or whatever, have it shipped to your house, and then just put it up without testing it? And the answer is, of course not. You're going to borrow a meter, or you're going to buy a meter, or you're going to get a nano VNA, and you're going to check the SWR of your antenna before you transmit on it. These things are pretty cheap now. They can get them for about 50 bucks. And well worth it. So that was open and short. Now I'm doing the 50 ohm load. And we'll save that. And we'll plug in our antenna. I had the bottom frequency at 400 megahertz. The top frequency is 550 megahertz. Let's see where we are. Now, remember, these numbers or these dimensions are going to be a little bit long. And right there, this one's actually tuned pretty good for the 70 centimeter ham band, which is way too low. But I'm also not picking it up and getting away from the bench, so we got to do that. So I'm just holding it away from the bench and away from my body by the bottom of it, like so. Just get it up in free air. And at 455.5 megahertz, we're 1.2 to 1. So we're a little bit low on frequency, so we need to trim. Now here's where it gets difficult, because since it's a UHF antenna, and our dimensions are short to begin with, we're only dealing with a 5.5 inch matching section here. It's really easy to overshoot your target. Luckily I have 10 minutes left, so we'll get this done. But one of the problems with J poles is there's two sections you have to match. You have the matching section down here, which resonates at your tuned frequency. And then you have your half-wave dipole, which also has to be matched. And what will happen is you can be on one and off on the other, and your SWR won't be good. So what you have to do is you have to take very, very short snips of the wire and watch your SWR very carefully and see where you end up going. So like if I snip 1/16 of an inch, and that's exactly what I'm talking about here. 1/16 of an inch off the matching section can make a huge change, and I'll show you that in just a second. But if I snip 1/16 of an inch off of this and the SWR gets worse, what that tells me is I'm moving away from the tuned dimension that the half-wave part of this antenna is. So right now they should both be low on frequency. That's how I've got this set up. But when I start snipping both ends of this, I have to watch my SWR, because when I'm the correct length on both of these sections, the SWR will be flat out. And then if I snip one and not the other, the SWR will go up and the resonant frequency will change slightly. So we know we're a little bit low, so what I need to do now is get an SWR reading and a frequency reading, and then I need to remember that number, take my adjustment, make my snip, and then see which way it goes. So okay, I'm going to hold this up, and we're 1.25 to 1 at exactly 454 megahertz. And I'm going to write that down. So 1.25 at 450. Now I'm going to snip 1/8 of an inch or 1/16 of an inch off the short leg matching section and check it again. So I'm going to take 1/16 of an inch off of this one. And we'll check it again. Now the SWR is either going to get worse or get better. And it got better. So we're now 1.13 to 1 at 455 megahertz. So that tells me I'm going in the right direction. It's actually 1.12 at 457, but you get the idea. So I'm going to take another 1/16 of an inch off the matching section. And put it back together and check it again. And we came down once again. So now we're 1.05 to 1 at 458.5. Now it gets questionable whether I can go any lower. Yeah, I'm going to take one more snip off the matching section. So one more snip off the matching section. I think that's going to be it. And I'll have to move to the long leg. So I'm taking the absolute smallest amount that I can here. And putting it back in the tube. And we'll hold it out again. And there we go. So it still came down a little bit. So now we are 1.08. And that's about the same. At 461.5. Now I'm going to run this up and I'm going to see what it is at 468. So it's a little bit, it's still a little bit low on frequency. At 467.500 we're 1.6 to 1. So now it's time to start shortening the long leg. So I'm going to take about that much. It's about 1/8 of an inch off the long leg. And once again, I'm going to hold at the bottom, put it up in free air, and it's about the same. Let me take a little more. It's about another 1/8 of an inch. That made a change. So now we're 1.08 at 463 megahertz. And honestly, I think that might be good enough. So I'm holding it out in free air. And I'm going to go down to, there's 460 at 1.2 megahertz, and I'm going to run it up to 468 megahertz, which is higher than any GMRS channel that you're going to use. So 467, 500, 468, it's 1.57 to 1. Actually, that's 469. Let me tighten this up a little bit. So our lowest, let's see, I'll go from 451 to, or 450 to 470. So 450 to 470. Okay, there's 469 megahertz, which is above any GMRS channel that you're going to use, and we're still pretty good. There's 468, 1.5. It goes 1.49 at 467, 600. And then we are 1.01 at 463. And at 462 flat, we're 1.1. So there you have it. 18 minutes and 41 seconds, and I am almost done. So now what we got to do is we're going to just put a very slight bend at the top of this, like so. And all that's for is I'm going to take a piece of string, I'm going to tie a knot. Just going to use a square knot. And what that's for is just to put some tension at the top of our tube. So when I feed this in, feed it in string first, and then slide it in, and then that string should come out the other end, like so. So here's our string coming out the other end, and then we just stick our cap on there to hold it. Now, full disclosure, I don't have another cap. I only have the one cap, but I also have this adapter which will work for this purpose, just to illustrate what's going on here. But when you shove the other cap on there, it's going to hold that string, and it's going to keep tension on that wire so that tension can't sag or bend or anything. So there's some pretty good tension on that wire right now. And this is it. This is our completed antenna. So we'd have a cap up here, and then at the other end this cap just pushes on. Got our coax through the bottom, and then our antenna actually starts a foot up this tube. So we cut this, by the way, we cut this section of pipe 30 inches. So that's going to be 30 inches long. And the reason I made it 30 inches is because the antenna doesn't start until a foot up the pipe. So it starts way up here. And this bottom section is what we clamp to our mast or to the roof or whatever we're going to clamp this thing to. So you can take 2 hose clamps, clamp this to a mast, put it up in the air, and have astonishingly good SWR out of an antenna that you can make in 20 minutes. So 21.45 minutes, I'm going to stop that right there. And there you have it. Very simple antenna to make. And you can make it out of stuff that you have laying around your house. If you happen to have some of this tubing, Home Depot sells it, Lowe's sells it. It's very cheap. I think a 10-foot section of this is about $5. The caps are, roughly $1 a piece. The house wire, I scavenged it off of another project here I had at the house. It's 14 gauge insulated, and you just cut that to about 29 inches to start with. This is what I had left over when I cut it to size, and throw it together. This makes a great base antenna. It doesn't need radials. It probably should have an air choke at the bottom, and I'll show you how to make that. So as close to the antenna as you can get. Just take your coax and make 5-inch circles about like this, and make 3 or 4 loops like so, and then just zip tie that to your mast and barrel connect this to your coax. Make sure you use really good coax. If you have a really long run, you want to use something like LMR 400. If it's a shorter run, you can get by with something else. My run's only about 25 feet, so I'm using LMR 240, which works just fine. But yeah, there you have it. Simple J Pole, really quick to make it. They perform fabulously. And hey, thanks for watching.